right, the last type of graph for numerical data that we are going to talk about is we are going to talk about a histogram. This is by far the most popular type of graphs for numerical data. Right? So in a histogram, right, we record data by grouping observations into intervals or classes called bins. Right? We saw that back when we were looking at our first frequency distribution. The width of each of these rectangles or classes is the same. The height of each rectangle is the frequency or relative frequency of each observational class. Right? So as we're working through and as we're thinking about this, again, it's going to tie back to our frequency distributions that we set up in our first couple of examples in this section. Our lower class limit is the smallest value within the class. The upper class limit is the largest value within the class. The class width is the difference between consecutive class limits. That's going to tell us how wide our group or our class is. If a data point falls on the boundary of two classes and it's placed in the bin or class on the right, the bin width makes for a difference in the histogram. So the last couple of statements there, bin width makes for a difference in the histogram. We'll kind of see that as we're working through some examples. And talking about where the data points fall, if it falls on the boundary of two classes, it's placed to the right. That's going to be connected to our interval notation that we saw when we were working through and looking at our frequency distribution when we were working with bins and classes. Okay, so before we get into actually constructing a histogram, we're going to talk a little bit about interpreting that, because again, interpretation is the end goal when we're working through our data cycle. So again, same example that we started with from the beginning, right? So we are still looking at our data for our soccer players. Right? We're asked to create a histogram for the data, answer the following questions about the histogram created for the data. To match the given histogram using StatCrunch, start a bin at 9, use the width of 3. Again, there will be kind of a more detailed explanation on D2L going through those different steps. But for right now, we're not going to worry too much about creating a histogram until we get into the next example, but we're going to look at how we can analyze this one that we're given. So this has taken this data set that we have here and grouped our data into these classes or bins. So first thing that we are asked here, what is the class width? Right? So in order to find our class width, we can subtract any two of these values. So it doesn't matter what we pick. So we're going to pick just the first three. 12 minus 9 equals 3. So we have a class width of 3. This interval shown between 12 and 15. Remember that our lower limit, we're going to include that 12, right? And then our upper limit is going to be 14, because this interval, right, is from 12 to 15. Well, the 12 is included, but the 15 is not. So our lower limit is 12, and our upper limit is 14 instead of 15. How many players fell into this class between 12 and 15? Right, so looking at this using our frequency label along the left, right, we go up, we see that list lines up with the frequency of 9. So we're going to say 9 players. Right, what percent of players fell into this class? Remember, percent equals part divided by whole, as we've been doing. 9 divided by 28 equals 0.3214, which then if we round this off to a percent, we are going to get 32.1%. Right, so same types of interpretation questions that we saw when we were looking at our dot plots. Right, so no matter what type of visual representation you're given of your numerical data set, you should be able to answer these types of questions. Right, this one we just investigated a little more with our class width and our class limits. There's a little note here at the bottom. The bin width or class width does make a difference in a histogram. Right? The histograms below show, or off to the side I should say, show the same information but with a different bin or class. Right? So here, same data set that we saw up here, right? But what we've done here is shown individual data values, so we only have a class width of 1. Here we have class widths of a lot larger, right? So we've got class widths of 20, between 9 and 29 and 20 and 49. And that doesn't give us much detail at all about our data set. So a width that is too narrow, as in A, shows too much detail. A width that is too wide, as in B, hides too much detail. Right? So that's why we pick something that's kind of in between. We used a class width of 3 up here at the top. Most technology, including StatCrunch, automatically chooses bin widths for an initial look at the data, but you can always play around with adjusting the bin width to see if anything interesting appears. So generally speaking, if you're asked to create a histogram using StatCrunch, it will generally automatically decide what it thinks is an appropriate class width. However, you do have the ability to go through and change it. Again, take a look at the information online about StatCrunch to give you a little bit more detail about that.